Welcome everyone. Thank you guys all for joining us today for BigRep's community training session. Today's topic is on post-processing. So this is often one of the most forgotten and very underutilized steps in 3D printing. And I am joined today this way on my screen with Lindsay Lawson, and she is one of our 3D printing rock stars. I've decided that that should be a new title at BigRep. But she has a wealth of knowledge. She's actually one that wrote our post-processing guide. So she is going to walk you through kind of the ins and outs of post-processing, all the way from support removals up to different things that you can do to strengthen your part, change the aesthetics. I think she's even going to do a little on-screen demo of some things, and I know she's got lots of sample parts there as well that she can walk you through. If you have any questions, I know some people submitted those when you registered, so we've got those, and Lindsay has those as well. But if you have any while she's presenting and talking, feel free to type those into the chat. And if you're feeling super brave this morning or afternoon for wherever you're at, you can also unmute yourself and ask that. So we can do some questions as we go, and then we'll also save about 5-10 minutes at the end to do more questions there. So without that, I am going to turn things over to Lindsay.
Hello, everybody. Welcome. So I'm just going to get right to it. As Abby said, we're going to look at post-processing 3D prints with a focus on FFF, because that's what we do at BigRep. Yeah, so let's get started. Okay. So what I'm going to cover today is what is post-processing. Then we'll have a closer look at the print layers. We'll talk about 3 categories of post-processing, and across those 3 categories, I'll show you an overview of 16 methods. Then I'll talk a little bit about the added value of post-processing generally, aside from what method you might be interested in. And then I'll do a simple live demo of a resin coating, and we can have some questions at the end. I don't know if, Abby, if you normally share these slide sets, but I put, we have a new post-processing page on the BigRep website, which I put the URL at the bottom of this slide. And it's just been updated. So a lot of the content I'll go over here today is expanded in that website. So have a look. Okay, so what is post-processing? Simply anything that you do to a print after you remove it from the print bed. So this would mean, of course, support removal, which if you're already printing, you're probably familiar with. A really common one is surface smoothing, especially for FFF prints, especially large-scale prints like BigRep printers. The layer heights tend to be a bit higher because of the scale of the parts. So you get these sort of surface layers that are visible, and often that's something that is not desired for aesthetic reasons or otherwise. Also part assembly, sometimes you may want to combine 2 prints to make a bigger print, or you may want to combine 2 prints that were printed in different orientations for the best possible printing and then assemble them later. Of course, aesthetic finishing, as I mentioned. There's also all kinds of functional coatings and more. So let's look at a few pictures here. So the image you see on the left is a print that still has all the support on it. The one in the middle top is a sample I have here. I can show you, which has been post-processed on one side. So it has, can't really see myself. Let me see really quick so I can see if I'm in the frame here. Okay, yeah, there we go. So this side has been coated. It's super smooth. You don't see any visible lines or anything like that. And the other side is the original print. So you can kind of see there. The picture on the bottom middle is a functional coating, which is metal plated for a gas tank. And the picture on the right is a sculpture that has a kind of unique aesthetic finishing, texture, and color added to it. So print layers. So if everyone in this call here has printed before, you have a basic concept of this at least. So all 3D prints are made layer by layer in some way or another. In FFF printing, it's heated plastic that's extruded and kind of squeezed out layer by layer to build up a print. Moving up in the Z-axis. This is called the staircase effect, when we start to see these sort of ridges. And for example, like the more shallow the angle is of a part, if you look at the picture on the bottom right of this blue part, the more you're going to see these sort of staircase steps. Let's see if I can picture. Oh, anyway, okay. So often, what people want to do with post processing is remove these layers and staircases for surface smoothing. Aside from smoothing and any other kind of aesthetic changes you might want to make, there's a few other reasons to perhaps do some post processing. One is that if your part has really specific requirements and tolerances, these notches in between layers may be too large for the part requirement. Maybe it needs to be really precise, or maybe you've been printing really high layer heights that's getting into the several millimeter. Also, the prints are weakest at their layer intersections where it's bonded. And it may be that you just simply want to strengthen the part. So that's another reason. So now straight on to the three categories. And the first one is subtractive, which is simply removing material from your print. The second one is additive, adding material onto your print. The third is property changing. So you're going to be not removing or adding anything, but you're going to redistribute the molecules of the print material for various reasons. We'll get into that when we look at some examples. Okay, so first I'm just going to go through a whole bunch of methods, starting with the subtractive. So sanding and polishing is probably one of the simplest ones. You may have tried yourself, which is simply sanding the parts, which can be done by hand. It can be done with a tool. It can be automated even with robotic arms. Just like any sort of sanding with like a typical like wood, for example, you would start with a rougher grit for the bigger layers, and then you can work your way down to a finer grit and even polishing cloth or polishing paste to get it really smooth. The pros for this are that it's really easy. Like I have a sample here. This is what I'm going to post process later. It's just a really simple cylinder, the layers here. And if I was going to sand this, I could just take some sandpaper and just go at it with the roughest one first. So it's super easy and affordable, just getting into that. Already here you see, I don't know if you can see this so well, but not so much. It's kind of dark in here. Anyhow, super easy and affordable. The problem is that it is rather time consuming to do it by hand. It's not typically automated. It's rare that someone would go the route where they actually automate it, but even though you could, it's not uniform because you're doing it by hand, and some materials don't really respond to sanding. TPU, for example, is very difficult, if not impossible, to sand. So moving forward.
Sorry, Lindsay, one question.
Yes.
TPU doesn't work well. Somebody asked what material would you say works best with it, with sanding?
I think that was actually one of the questions I got in the registration. I'm not sure, which I actually typed out some of them at the end of this. But for sanding, pretty much any material that BigRep offers, and I'm not talking about soluble supports because you're basically never going to post-process those. You want to just remove them with water. So any material other than TPU that BigRep offers is pretty much the same level of easy to sand. It's not that hard. The PA666 will be more difficult somewhat, but TPU is the difficult one because imagine, TPU is a really flexible material and it just doesn't respond well to sanding. The easiest by far is the PLA ultralight, which is a foam material. So it's a PLA foam that when it's printed and heats in the extruder, it foams up. And so basically it's part of it is air bubbles. And so if you're looking for something really easy to sand, maybe it's for a piece that's just like a show piece and it doesn't have to have some other kind of functional properties. That one's super easy. I mean, you could do it by hand really easily. So that's maybe an option if you're really looking for something that you can sand super easily. Okay, so next one is tumbling. So tumbling is simply putting a part into a vibrating vat of abrasive media. Often there's a lubricant. It can just be water, but you can also use abrasive chemicals that sort of doubly function to break down the surface. Here we go. And so the abrasive media, I have one here. I'll show you. This is a little piece of ceramic. Um, Basically, they come in all kinds of shapes and sizes and materials. You see the two pictures I have there. The top picture is pretty similar to what I have here. The bottom one, I believe, is also ceramic. I'm not exactly sure. But the shape, size, and material you choose for your abrasive media is going to be really dependent on the print itself and the material. I have a sample here I can show you. This is one of the samples that I made for this post-processing study that we did internally at BigRep a couple of years ago. This one was put in a small tumbler, and it did pretty well. I mean, you see the sort of the lightness in color, which is from this kind of scratching away. Some of these layers are a bit more pronounced, so it didn't quite. I mean, basically, there's gaps in them, so you can kind of still see it. But it actually, I mean, it feels quite smooth to me here. Like this top side is super smooth. We've also got another geometry from the same study. These were also put into a tumbler, and you see that it's quite smooth. I don't know if you can see maybe that reflection. The only downside with tumbling is that you might start to lose these sharper edges. So here, for example, this edge goes from rounded to it's actually quite sharp in the original print, and this has kind of gotten worn off a little bit. The cool thing is though, the staircases at the top are really quite smooth. This sample was designed intentionally to be difficult to post-process to see what works well and what doesn't. So it fares pretty well. The pros for tumbling is that it's automated. You just throw it in. You can reuse the abrasive material for a long time, and you can do a lot of prints simultaneously. So, for example, I want to say this was maybe around somewhere between 12 and 18 hours post-processing, but you could also have many of them in one vat and do it all at the same time. So your time per part and therefore cost per part can be reduced a lot if you're doing bigger batches. All right, so moving on. Abrasive blasting, also sandblasting. And this is simply blasting abrasive material onto the part at a high pressure. Usually it's sand or plastic beads. You can do it in a chamber like you see in the photo here, which can then recycle the abrasive material. It vacuums it up and puts it back into the system so you reuse it. Again, you would want to choose your abrasive material based on the print and the roughness. It's pretty important here because the abrasive material is finer than that of tumbling, that if it's too fine, it can actually increase the appearance of layers because it gets in between them and kind of eats those notches out in a way. So it's important to have the right correlation to the size of your print and print layers. The pros, it can be done outside for larger parts, so you can just simply spray it onto, or you can, as I mentioned, put it in a chamber and recycle the material. I don't have the sample that we did for the study of abrasive blasting because it actually wasn't so effective in our testing. In that study, we worked only with one company who specializes in that. And I found that they didn't really take an experimental approach to trying things out because they're not typically blasting plastic prints. So it's something you have to experiment with, but it's certainly possible. It's also less effective on rougher parts because of the size of the abrasive material, and doesn't really work so well on complex shapes where there's a cavity or like, I mean, you could spray into here, but if you have a really internal structure, you're not going to be able to reach it with the tool head. All right, moving on.
Lindsay, does the abrasive blasting work with all materials, or are there certain ones that you wouldn't do it with?
It's kind of the same as the sanding. Anything that's a mechanical process of basically abrading the surface. Um, the PLA ultralight is going to be the easiest. You'd almost have to be careful that you don't overdo it because it's more brittle and it's it has this real foamy. Even though it's a rigid foam, it's a foam structure. The rest of the materials shouldn't behave too differently. It would take a little bit of experimentation, but I'd say roughly the same, except for again TPU. So anything that you're going to abrade with a mechanical process, TPU is going to be a problem. The rest kind of give or take similar, and PLA ultralight super easy. Okay, so CNC milling. So we did this in the test in the post processing study. We had a piece milled just to see what it looks like. So milling is simply a tool head that is it basically it's kind of like the inverse of 3D printing. Instead of a tool head moving around extruding material, it's a tool head moving around and cutting away from a block of material. Um, it's a little bit of a weird thing to do with the 3D print because you're again sort of doubling the work you're doing. So it's I'm skipping now to the cons here, but it can be sort of expensive and time consuming. I mean, if you're going to mill a print, why not just mill it in the first place? The only reason being, um, if for some reason the material is very expensive, you won't be wasting as much material from a big block that you'd have to cut away from. Another con is that when you have a 3D print, it's not always it's never always exactly what your 3D model is because it's been at the very least it's been turned into print layers now, and so you have these little notches, even if it's quite a accurate print. So you need to calibrate your milling machine so that it knows exactly where your print is, but also your print may have slight deviations. So that's something to keep in mind. The pros for it, it's super smooth, very precise, and you can post-process very specific areas. So it's one I would rarely recommend, but occasionally it could be interesting if, for example, say I have this print and I just really need a certain edge to be super fine, super sharp, you know, I could go in and CNC mill just a little section of it where that's important. Could be interesting. All right, chemical dipping. Here we have a sample that was, this was, yeah, this was dipped. Yes, only dipped. And basically it is the picture you see here is pretty standard practice for removing paint and rust from a car. But the part is submerged in a chemical bath that will eat away the surface material. The chemical use is then, of course, dependent on what the material of that object is. Um, it's not something that's so easy to do, so it really requires some expertise and knowing also how long the part needs to be submerged. The pros are that it can be automated. It can post-process complex geometries. So if you have a really complex matrix structure or internal cavities, the liquid can get in there. Um, the cons are that for chemical dipping a 3D print, you may be limited to the size of the dipping vat because typically, I mean, with the car picture there, there's a whole industry for that, but there's not so many people really getting into that for larger 3D prints. So that's something to consider. And also, you're just dealing with dangerous chemicals, so it's not really for the person sort of dipping their toe into post processing. But if you work with somebody who is really experienced in this, could be interesting for you. It's an option. Okay, oops, let's see. I think that was just checking. Okay, yeah, so now we're on to additive, and there's a whole bunch of them. There's a bit more in this section, and I will start with filling. So filling is simply putting a filler onto the surface of the print. It's typically like more of a paste, although there are also spray fillers that are thinner, yeah, more like a liquid that might have a little bit of texture in them that's kind of gives a thickness. Yeah, so normally you just apply it by hand. You might just kind of spackle it on, smear it on. And there's a lot of different range of filler materials. The pros are that it fills large gaps. It's super easy. You're doing it by hand. It's affordable. You could even automate it as a spray, but again, the spray won't be as yeah, it won't tackle such big gaps. This is a sample that has been just kind of smeared with a filler. And typically with fillers, because if you're using a paste, it's quite thick. You're almost always going to want to follow it with sanding. Um, if you get a filler that is a little bit of like a lighter spackle, then that's super easy. You can just fill it. You can even use the kinds of fillers you would get for your house to fill a hole in a wall and fill the layer gaps like that, and then sand it off really easily. Some of them are super light to sand. The cons are that it can be time consuming if you're doing this by hand. And again, as you see this sample, it's really not precise. It's me just kind of smearing it on this thing. And as I mentioned, usually requiring sanding. So this is just like a sort of home spackle, but it's actually pretty robust, this surface. And this is actually really old. This is one of the first sample kits I made for post-processing when I started working here, I think maybe like 4 years ago. But there's also, for example, like this is another spackle that is actually for auto repair. And it's a 2-component spackle that's a plastic that has a activator here. And so you mix it together, yeah, with a hardener. And this is also super robust and strong. So there's just a few we have laying around that we've used before, but they're really effective. The picture you see in the top of this slide here is a client of ours who was making bathtub prototypes, filling them, post-processing them to make them super smooth. And when they decided, yeah, this is the design we want to make, then they would go on to make the bathtub in the traditional methods, but they needed to have like a really perfect prototype. All right, so next is priming. It's really just a pre-treatment for the surface. It's, yeah, pretty much only used as a preparation for a subsequent material to be coated. Better adhesion. It can slightly smooth the surface. This is typically a spray coating, but you could also get something that's a brush-on primer. It's really easy, affordable, but the cons again are that it's not really smoothing much, and it certainly requires additional coatings. I have one here I've used before. This is by Loctite. I have a few samples of materials here from them, and they make a number of. This is actually by Henkel, but Loctite is the brand. They make a number of 3D printing specific materials, and these are pretty cool. They call this a smoothing beige primer. So in 30 minutes, you can already sand it if you like. I've used this before. It does do a real slight smoothing, but again, because of BigRep prints, the scale really changes things. So typically your layer height on these prints is much higher than a desktop printer. So it's not going to do as much for smoothing, but it is a good primer. And maybe if you have a print with a really fine layer height, this could have a slight smoothing effect. So.
Lindsay, somebody's asking what materials are best suited for priming.
What print materials?
Yes.
I would say with these, I mean, you want to make sure something corresponds to the material itself. So usually these have a list of what kinds of polymers work. I would say again, TPU. I never tried this on TPU, so I don't know how well it would adhere. And you usually are using TPU for its flexibility, so you would also need a primer that can bend without cracking or coming off. But this should work on pretty much anything else that BigRep sells. So. Yeah. Okay. Brush coating. So this is actually what I'm going to show you in the demo at the end. And brush coating is simply applying a liquid coating with the brush. This could be paint. This could be 2-component resins, which is what I'll show you. It's pretty easy, affordable. It's not really something you would automate ever, but yeah, it's a pretty easy way to do surface smoothing. The cons are that you can leave brush strokes. It can be a bit time consuming to do. But what I'll show you at the end of today is we'll do a quick demo. Some of you are probably familiar with this because I think I saw in some of the registrations that some people are using this. But this is a 2-component resin called XTC 3D that's made by Smooth On. They're a California-based company that makes a whole bunch of mold making, casting, all kinds of materials like that. And this one's specifically formulated for 3D prints in general. So it'll pretty much adhere to anything that BigRep can print with. And the cool thing about this is that it's formulated to be self-leveling. So that means that when you brush it onto the print, the brush strokes kind of just even themselves out because of the viscosity of the material. It's runny enough that it's not leaving these thick streaks from the brush, but it's also thick enough that it doesn't drip off the part if you apply it properly. So usually if somebody's looking just for surface smoothing and there's no issue to have a coating on it, meaning that it's okay that it has a second material, this would usually be my go-to solution because it's quite easy to do. And the results are really good. Yeah, so moving on. Spray coating, basically the same as brush coating, except now you're spraying. So you could do this with a whole bunch of different materials, primers, paints, resins, all kinds of things. The cool thing is it's really scalable. So this is something you could do in an industrial setting. We did some samples here. Let's see. This, for example, is coated with a spray coat. It's super glossy. It has this really thick coat. And this is actually a material that's super expensive. It's put inside of tunnels to keep water out, essentially. So it's a really industrial material that you wouldn't use for just simply surface smoothing. But we wanted to just see how smooth this could get. So it's a really thick layer. This is just one example, but there's tons of things you can spray on. And it's generally just like an easy way to do something. You can it can be pretty uniform, especially if it's done with a robotic arm. The cons are that you need to be a little bit more careful about ventilation. It might be difficult to treat cavities or certain geometries where the spray can't really reach into. What you see on the picture at the top here is some samples from some pieces we had done at BigRep as some tests. And I showed some pictures in the beginning. There'll be some more at the end of this, but they're really super smooth. So I think what's being sprayed on here is a 2-component resin coating. Okay, so foiling. Probably most people have never tried this on a 3D print, I'm guessing. If you know of foiling, you probably know it more from automotive industry. But this is simply when an adhesive foil is wrapped onto a object. With car foils, they're usually like plastics. They can be all kinds of colors, patterns, different aesthetic looks. They can also be thin metal foils with an adhesive backing. We have a few samples from the study here. So this is a plastic foil. See, it's trimmed to the edge here. And this was done with a vacuum foiler. So there's like it's put into a vacuum chamber that kind of sucks it on. And it actually does quite well. We didn't do it on this geometry because it's not possible. It can't get into these kind of grooves here. So with this though, it's really quite good. The only thing is, I don't know if you can see so well, but when these little ridges here, when the height gets higher and therefore the valley is sort of deeper, it's not quite going all the way down. So yeah, it's a lot more limited onto what kind of geometries you can apply the foil, but for more like kind of gently sloping, this is another one, for more gently sloping kind of geometries, this is actually really interesting, and it might also have some kind of added functionality, some kinds of resistance depending on what foil you want. And these have been sitting around for a few years and they are still sticking here. So they're usually pretty robust. Okay. Next one is dip coating. So this is just another way to apply a liquid coating to an object. But in this case, you would submerge the print into a vat of an additive material like this paint, resin. You could do rubber even. It's interesting because it can be redipped and make a thicker coating that also even more smooths the layer structure. There's also a specific kind of dip coating. I don't have a sample here, but it's called hydro dipping or water transfer printing. And this is where the picture at the bottom you see, you either have a special printed foil that sits on the top of the water surface, or you can do it with different kinds of special oil-based paints that are, again, kind of just floating on the surface of the water. And you submerge your part through this top layer of material and it adheres to it and makes some really cool finishes. It's something you also see in sort of car finishing for sort of fancy detailing. The pros with dipping here are that you get a really uniform finish and you can treat complex geometries and cavities. The cons are when you're dipping it, you have to hold the object at some point. So wherever it's being held, it will not be treated. Also, if you have really large parts, it's going to be maybe difficult due to the size because you need a vat even bigger than that. You may also need an additional coating material, like for example, with the hydro dipping water transfer printing.
Question, Lindsay. Sorry, on the
Yeah.
dipping, do you have to do anything to the part before you dip it? Like, is there a step between pulling it off the bed and removing the supports to dipping it?
It depends on what material you want to use. So if you're doing some kind of two-component like resin type thing, no. Paint, maybe not also, but you might, yeah, it might be better to prime it first. So it's always just making sure that the material you're using will adhere to the print material. So you have to kind of check. It really depends on uh, on what you want to use for your coating material. All right, so metal plating. So we got a few examples here. So metal plating is a chemical process where the print is coated with with a layer of metal, but this is actually two steps because with 3D prints, at least the ones that come out of BigRep machines, they're all some kind of polymer, and they need to be first coated with a metal-based solvent or paint or something. Whoops. So that's called electrolysis plating. And I mean, there's DIY kits. You can do this yourself. There's people that do this service. Here's a few samples I have. This is a manifold sample that we've made at BigRep, and this was done, I think, by an Israeli company. They have their own proprietary metal plating process for 3D prints. This one's really thin, and you can really still see all of the surface layers here. It does a little bit of smoothing, but not so much. But this is interesting. Maybe it's more of a functional coating. Some of the areas are a bit thicker though. Like, I don't know if you can see here, but this part is actually quite smooth. Then there's this other sample. It's another company, has their own process to do this. This one, I specifically asked them, try to smooth this part. So this is copper plated, and you still see some of the layers, but it is smoother than this silver colored one here. Yeah, and this is, I mean, this is real copper. You see how it's oxidizing, so I could clean this off to remove this. But basically the process is that you first coat it with a coating that is metallizes it. And then the second layer is, it can be electroplated or a sort of metal acid solution. There's a whole bunch of range of metals. Typically the first layer might be something more inexpensive, like you might have a copper layer underneath and then something else over top. And you can do a third layer that is like a final protective layer. For example, if you want to protect against corrosion or something like this. The pros are that it's very robust. I mean, this is heavier for sure than the other pieces. It's really like a thick a relatively thick layer of copper. So it's quite robust, it's functional. Somebody in the registration comments had asked about conductivity. And so, I mean, this is, yeah, this is definitely conductive. You get a pretty uniform finish. There's some slight variation, some areas a little bit thicker, but it's pretty uniform. It can definitely treat cavities, although it's not as good as you might expect. It doesn't quite reach sometimes, and that could just be a matter of testing, because these are kind of experiments. But it's the cons are that it does, as I mentioned, require several steps. The part size is limited because you're often going to put it in some kind of, or you have to put it in some kind of vat. So you're limited to that. And it can be expensive. Yeah, but really great and effective. And if you're looking for just smoothing, maybe it's a bit expensive, but if you're looking for a functional part, it's not so bad. I think this piece was maybe around 200 to coat. So, I mean, expensive depends on what you're trying to do. That's not outrageous. All right, powder coating. I don't have the sample here, but it is bad. So maybe okay that you don't see it. Powder coating is simply coating a part in with a cloud of powdered plastic. There's also rotational centering is similar concept, except that it's a heated chamber, and the part is spinning in this chamber. So the bottom picture you see there is kind of an image of rotational centering. And this is typically done with metal parts. It's really common to see, actually. But it's a little bit difficult with plastic prints because of the temperature requirements. Usually it's heating involved. So the samples that we had done, it was again kind of an experiment, and it sort of melted some of the pieces a bit. But that was also using a really standard PLA. So if you were interested in powder coating, you'd have to experiment a little bit with somebody that was open for that. But if you use a more higher temperature resistant material like high temp CF or just high temp, you might get pretty good results, actually, because the sample we had, actually parts of it did look quite good. It just deformed other parts. But yeah, the pros are it's a uniform finish. It's smooth with a sort of typical matte finish that you know for powder coating. It looks nice. Yeah, but as I mentioned, the cons, it's not so commonly done with 3D prints. There's a little bit of experimenting, and it may be difficult to achieve. Okay, and now we're on to the third method, or third category, I mean, which is property changing. So the first one, probably if you've ever 3D printed something, you might have tried this. It's just local melting. So you simply heat an area of a print to either remove minor scratches. You may have a print that has like little strings hanging off of it from when the print head is moving, so they're oozing during travel moves, things like that. So you can simply use a heat gun and just heat the area for a few seconds. You can also use a torch like this kind of thing here. And the pros are that it's super easy, it's affordable, it's really effective for small scuffs. Let me see if you can see this here. Maybe now you see, yeah. So see how this has this kind of scuffs here? Let's see if I can, nope. Of course, I can't get it started now on camera. Uh-oh. Well, crap. Okay, I'm gonna have to skip this. This isn't turning on now. But normally I would just take a heat gun or this little torch and just hit this here. And with dark prints, if you sand them, they kind of lighten, and that will pretty much take that away with some like light scratches. You know, it's really effective. Like you can see here, this edge is kind of rough. If I hit that with the torch here, that'll all go away. The cons are that it's really easy to deform your part. If you just hold it for a few seconds, it's good. But if you do it even a few seconds too long, you can already deform your part and it kind of sags and melts in a weird way. So it's really not suitable for smoothing an entire print. And it's only for really lighter scratches, kind of surface things. A deep area, it's too much. Will deform the part a lot. Annealing. So here we go. So annealing is the process of strengthening a part by heating it. This reorganizes the molecular structure of that material, and it reduces the internal stress and strengthens the part. So annealing is something that's typically done to metals. So you can heat the metal part for very specific amounts of times at certain temperatures for certain durations, and that will result in a stronger part. But you can also do it with prints and polymers. So there was a sample we made some time ago for this. So this is the hubcap of like a student race car. And typically this was made with carbon fiber prepreg, you see here, that was put into an autoclave. And so, and then this hardware attached to it here. And so typically you would have an aluminum positive form milled, and then you would do the prepreg over top of it for the mold making, but that's really expensive. And since this was a student project, they reached out to us and we printed this mold form here. I don't think this is the actual, this is just a sample of the one we did because we used a different material that was specifically made for high temp and for annealing. And so basically we printed this, we put it in the oven by itself before to anneal it, which then made it more temperature resistant for the later mold making process. So the cool thing is that it basically, you need to get the part heated to the point that it's hitting the glass transition temperature, but not melting it and deforming it. So it basically kind of smooths out the inner structure of the molecules that are like amorphous and makes it more like a semi-crystalline structure. So it doesn't do anything for part smoothing, but it can increase strength and temperature resistance. So it will probably shrink a little bit though. So it's, again, something that's, yeah, it's a really kind of specific use. And you'd have to experiment a little bit with what you're doing, but it can be interesting for some applications. Okay, last one I will cover here is vapor smoothing. So vapor smoothing is exposing a print to vaporized solvents. And rather than dissolving them away like with the chemical dipping, it's rather redistributing the surface material. You can either heat the solvent or make a vapor from like an ultrasonic vibration. The surface tension of the part will ensure that the molecules kind of distribute themselves evenly. Again, like with the chemical dipping, you need to have the right solvent for that print material. I don't have a sample here, unfortunately. The pros are that it's really smooth. You can see in the bottom picture, there is a close-up of some layers, and you see how much it smooths it. It's really becomes very glossy. It's really uniform. It can treat complex geometries and cavities pretty much evenly. The big cons here are that you're working with dangerous chemicals. You are limited to the part size because it needs to fit within a chamber, and it's something that really requires a lot of expertise. So there is a chart here that is an overview of polymers to solvents. So what filaments can be treated with what solvents. All of these are dangerous to work with, even the acetone in this format. So it's something that we don't even experiment with here at BigRep because, yeah, that's not our primary business. But there are actually some companies now starting to make post-processing vapor smoothing machines, and that are also can work for FFF prints, for example, It used to be, you know, BigRep now offers a lot more materials. So Aza, things like that, we're getting into now, which is great. And those are a bit easier to post process with chemicals. Like the acetone is probably one of the easier ones. Yeah, but PLAs and things like basically the more sort of non-toxic your filament is, typically the more toxic the solvent is to treat it. So it's not something, unless you're really comfortable with knowing your chemistry, that you want to get into yourself. But there are options out there, and there are some companies making machines and offering services to do this. So that's pretty cool. All right, so I will just now jump into the added value, sort of how you might rethink post-processing and make it maybe a lot more of yeah, something you get into almost every time you print. So you could reduce your print time. Um, Rather than focusing on having a really fine print right out of the print bed, you can make a rougher print and then smoothen it. So for example, print time really directly correlates to layer height. So my example here is a print that's 20 hours at 0.3 millimeters will be 10 at 0.6. I think this is probably roughly 0.6, you know, so you're still going to see it, even if it's very, I mean, this is very uniform print, like it's a good print, but it still has this kind of texture. So depending on what you're doing, maybe it makes sense for you to cut that print time in half and then smoothen it out. Also, if you're planning to post-process anyway, I would definitely recommend going with a rougher, faster print, saving yourself time there. Another added value is that, you know, FFF prints, there's always some layer height, and especially with BigRep prints, because they're so large, the layer height is generally higher. So if you're interested in a surface smoothness, you can get way smoother results by post-processing. So maybe that's an option, is to go with something that's a bit rougher anyhow, and achieve a smoothness that's closer to other production methods like injection molding, things like that. You can get equal results with post-processing. You can also post-process just a certain area. I mean, like again, with this sample, you know, if there's a visible side where you need it smooth, you can only treat that part if needed. Of course, aesthetic enhancement. I talked about a lot of things here. You have color change, texture, glossy matte, faux finishes, surface prints, patterns. You can even increase transparency if you're working with PETG. So the example on the left are some sinks by a client of ours, and they faux finish them to look like a kind of rusty metal or wood, and it's really, really realistic. They look, you know, without touching them and then feeling that it's not a cold piece of stone, they look really realistic. The pictures on the top right are these sculptures that have coatings on them, and they're matte and glossy, and you can do all kinds of color effects. Also, with the picture on the bottom right, these are PETG prints, and if basically the layers that you see in the printing make it have this kind of silvery color, because the light is refracting within the roundness, like kind of roundness of these layers, if you're looking at it on a really small scale. So if you smooth out those layers, either by coating, which is usually the easiest, coating with like a resin, a clear resin, or by smoothing it with maybe vapor smoothing or something, you can make the part much more transparent, which is what you see below. And another added value is functionality. So you've got all kinds of resistances: UV, weather resistance, chemical resistance, increased part strength and durability. I mean, most coatings are going to add some kind of strength. Increased temperature resistance, you can have conductivity, any kind of specialty coating that might have anti-static or maybe fire resistance, all kinds of things. So if there's something that you need out of your print that is not that is maybe lacking in the print material, post-processing might be able to add that in some kind of functional coating. So I will just go ahead and start on this demo really quick. And then I'll save hopefully like 5 minutes, maybe more, to get some questions, if that's okay. I'm going to do this rather quickly so that we have a little more time for questions. So as I mentioned, this is the XTC 3D. It's a 2-component brush-on resin coating. And
Hey, Lindsay, I'm just
yeah,
gonna, you wanna just stop sharing your slides and then we can make you bigger so they can
Yeah.
see your demo a little closer?
there we go. All right. Okay, so this stuff is super easy. I like to do it by weight. It's even easier. But basically, you mix this 2-to-1 by volume. You can buy these kits. They come in bigger kits as well. I think that's the smallest one. And it comes with this little measuring cup. I, however, prefer to just do it by weight, which I also wrote in the notes in this slide. And so basically, I just have a little plastic container and I measure out the correct proportions. A quick note about this material. So this is made to cure really quickly. So usually within an hour, it says up to 4 hours, but I find an hour or 2 hours, it's already cured. And so that means that your pot life is really short. That means maybe 10 minutes working time before it's too cured. It's already getting kind of to a gel. So you have to work kind of quickly. Also, it's an exothermic reaction when this stuff cures. So that means that it heats, it gets hot. So you only want to mix a little bit at a time. Otherwise, you're going to have, if you mix a whole bunch of this up to here and let it sit for a few minutes, it might start to get really hot. It could even smoke. So the best practice is just to mix a little bit that you can use quickly within a few minutes and then mix more. So if you have a big part, just keep mixing it as you go. So what I would do here is just I just brought my little kitchen scale here and put my cup on it. Let's see if I can maybe make this so you can see better. Kind of, yeah, okay. I just tare it, so I'm at 0. And so the ratio for this by weight is 42 for the small one to 100. And I like to do it this way because I can be more precise, and I can also just use 1 cup and just mix it in together rather than having to clean a bunch of different things and scoop things out. So I'm going to put 10 grams roughly, hopefully precisely, of this part. Okay, there we go. And it has just this little pop. It's really like a shampoo bottle. Oh, you know what? I'm doing this really badly. I should have put on gloves first. So always wear gloves, keep yourself clean. You can get a skin reaction from this, but as far as resins go, I mean, all resins are somehow toxic, but this one's relatively mild. It's not really super smelly. It does have a smell, but it's not the worst out there. And then I take the smaller one, and since I'm doing it by weight here, I did 10 grams before. Now I'm doing 4.2 grams, and there we go. Okay. Really simple. Then you can take either a stirring stick. I'm going to just use this brush that I'm going to use to apply it anyhow and just mix it up. You want to make sure I put a really small amount here because my part is quite small and you don't really need that much. I could make more if it's a bit bigger. Got a loose hair there. Okay. And just make sure it's really mixed. Don't need to do too crazy. Yeah. Okay. A little bit of smell, but it's not so bad. Okay. Move this aside. And I'm going to use this because I didn't really prepare this working space. Okay. Okay. And then you really simply just brush it on. And this is what I wanted to show, just to show how easy this is, because it's really like, if you want a smooth surface, this is really the first thing I would recommend. So just a really thin layer, like so. You see it's got kind of some brush strokes, but doesn't take long for them to kind of just even out. It doesn't have to be too thick, or else it will sag a little bit, drip a little bit if it's super thick. But you can always do a few layers if you need to. So you can already see how the layers are kind of just disappearing there. And that's basically what it's going to look like once it's cured. If I'm really in a hurry, it's not so recommended, but you can heat it as well. Or if you're working in a particularly cold space, I've done this before where I really wanted to get it done, and I put a little space heater on the part nearby, and then it can cure as fast as 15 minutes. So um, yeah, it's pretty easy. Got a little lump in there. So yeah, if you can see how smooth it's getting, and that's really basically the result that you'll see once it's done here. So just keep going, and I will leave it to cure. Uh, so if you had a transparent PETG part, this would make it really super transparent, looking almost like this cup. It's pretty impressive. But it's rare that anyone needs that. So not the most useful post-processing, but it's kind of a cool trick. Okay, so are there any questions?
All right, I just had a couple here come in.
Mhm.
All right, let's see. What is your best recommendation for smoothing PLA?
Mhm. I would really suggest what I'm doing here. If it's really just a smooth surface, this is really the easiest thing. I mean, look, as long as you can reach the area with the brush, it works really well. And you can also sand it afterwards, paint it afterwards, anything, and you're also strengthening the part in addition to that. So I'm a big fan of this, what I'm doing right here, and it's 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 specifically formulated for 3D prints. It works on PLA. It works on pretty much any material that BigRep sells. And I mean, look at this results already. You see how smooth that is? I mean, that's what
Impressive.
it's going to look like. Yeah, and so I mean, it's you can kind of do anything with it. So that's my first advice. Unless there's some reason this doesn't work for your specific application.
Okay. Are there instructions on print settings to reduce post-processing?
Ah, yeah. Okay, I remember this one. This was one that was entered in the registration. Actually, I have. I can share my screen again. I have a few answers for some of these. So let's go. Questions. Okay. Yes. Okay. What methods improve surface finish without painting? Print settings to reduce post processing. Yeah. So the easiest thing to reduce post processing is to not require supports. Um, as I mentioned, you can have a lower layer height, but then you're increasing your printing time sometimes significantly. So if that's not a problem, then okay, lower layer heights. But you can get better results with post processing. So um, without post processing, though, there's a link here to this blog post with a video that is an interview with Marco Mattia, one of our colleagues here, who is also a really good designer. And he gives a lot of tips about how to remove the need for support or at least minimize. So that means designing with that in mind, but also slicing and orienting your printed part on the print bed in a way that's requiring the least amount of support. So if you don't want to post process, I would start there. That's the best starting point. So, all right. Oh,
All right, here's one that wasn't on the registration that just came in. After filling in painting when using a dry oven in the paint shop, do you have any tips for warpage?
okay. Of the print, you mean?
Yes.
I mean, the best thing would be to print with a material that's less likely to warp, which we have a range of materials. Especially the carbon fiber materials, I think are quite good with that. So I would suggest that. Otherwise, there's not so much you can do if you really need to heat the part. It depends on the temperature resistances of that specific print material. So go for the carbon fibers and the high temp materials, and that should greatly reduce it. Um, I would avoid using HT Pro HT. That's is going to be a little bit more tendency to warp. So yeah.
All right, great. Well, we are pretty much out of time here. This has been an amazing training session here on post-processing. So round of applause for Lindsay. Amazing job. Lots of great tips and tricks here. I do want to throw out there, I know we had a few people that had very specific questions. If you do have very specific questions, please just email me back when I send the recording to this out. And we can set you up with Lindsay and she can help maybe walk you through your specific case to get you some tips there. To get your BigRep parts either new surface finish, if you want to try this cool resin trick that she showed you. We can definitely get you some one-on-one advice there for that. So with that, I will share the recording for this probably tomorrow, so you guys can all watch it again. But if you have questions, need advice, please feel free to reach out to us, and we very much appreciate that you joined us today. So with that, stay safe, stay healthy, and go BigRep, and we'll see you guys soon.